Hello, this is Hans Adams from Nishimbo Micro Devices and welcome back to another product introduction video. Today we have a look to a new boost DC-DC converter for energy harvesting, a complete solution designed for powering small, low-power consuming IoT devices by extracting energy from photovoltaic cells. With this new device, Nishimbo contributes to make products available that help us protecting the environment and reducing waste with independent self-powered devices. But first of all, let's jump into the details to know what is the R1810 all about. Standalone wireless devices have a significant advantage reducing the cost and labor of replacing batteries. Such applications are, for example, wireless sensors for environmental measurements, controlling home and building automation or industrial controls. However, such photovoltaic cells usually supply a voltage which is way below the desired operating voltage of the application. Therefore, a special circuit is required that collects energy from the harvesting cells, converts and stores it in an external energy storage capacitor, followed by a regulation of the output voltage to the required level. The R1810 is especially tailored for this purpose and starts up with only 9 microwatt provided from a single cell photovoltaic element. The startup voltage is only 0.5 volts and once started, the operation continues even if the input voltage drops below 0.2 volt. It has a high efficiency performance of 66% at 5 microamp output current. This is an example of the application circuit with the R1810 and RP604 buck-boost DC-DC converter, powering individually or a combination of an MCU, sensor and wireless module. In this case, we selected to use a relatively small capacity energy storage device based on lithium-ion, such as the TDK Seracharge, Nichicon SLB series or NGK and Acera batteries. The buck-boost DC-DC converter stabilizes the fluctuating voltage of the energy storage device as it is charged and discharged during the operation of the circuit. 2 monitoring circuits indicate the status of the conversion process on the respective outputs. The input power good function becomes active when the output voltage falls below the output UVLO voltage and the DC-DC converter stops switching for at least 1.5 seconds. Another output power good function indicates that the output voltage level drops below 50 to 80% of its nominal level. This threshold is internally set and specified by the product version. A built-in reverse current protection is included to prevent a current flow from output to input when, for example, the light on the photovoltaic cell is blocked. As soon as the input voltage drops below the output voltage, the high-side MOSFET transistor is turned off to avoid a reverse current and draining the energy storage device. The advanced R1810 has an internally fixed maximum power point voltage and output voltage setting. The VMP voltage is the maximum power point control voltage for harvesting energy from the photovoltaic cell and is different for each cell type or brand. One is able to optimize the performance of the electrical circuit by selecting the appropriate voltage. As soon as there is sufficient energy available on the output and increases above the VMP level, the boost DC-DC converter will be unable to transfer energy from input to the energy storage device on the output. When the amount of transferred power exceeds the supplied power from the photovoltaic cell, the input voltage decreases below the VMP voltage and the DC-DC converter stops switching.